Hello everyone, my name is Sarba Guha, which is here where my mouse is, Sarba Guha, and I work at the LSTC Troy office, Michigan, USA. We will be doing some of the occupant modeling workshops. Now, these workshops are already available at our FTP site and can be downloaded. My suggestion is that you download it and print out this document and keep it beside you while we are going through it so that you can read it and refer to it all the time. Now, we will be first doing workshop 1. This is the workshop. One more thing I would like to say, and that is I am personally a Linux worker. That means I like Linux much better than Windows. And Linux allows long path names and file names. Like you might have noticed if you have downloaded this package, there are long path names of directories and also long names of the files involved. Now, but I have later realized that Windows does not like such long names, and after some time they start giving problems. Now, if that is the case, you can, as soon as you download the first package, rename that package to something you understand, and then if you are able to unzip it, rename some of the one of the top directory names so that also becomes short. The main directory names I think you should keep so that you can understand where you are by reading the notes. Now, it says launch LSPP from the file drop-down menu. So we will be going to this directory first, sled learning aid. And we are launching LSPP. My version is 21st April 2017, which is quite a recent version of LSP Post. And I am trying to do this recording on April 30th, 2017. So this is a very recent version of LSP Post. So from the file drop-down menu, I import LS-DYNA keyword file. And the file I would like to import is DYNA. It has an extension K. This is how Windows writes it. I name my DYNA files with extension .k. Now, DYNA is the main file or the master file, and inside it, other files are included. So let us import this DYNA file for now. And we get to this model. This is our basic model with which we will be trying to teach everything. And these dummy models are simplistic versions. We have much better dummy models now, refined mesh models, which are the ones we recommend that people use. But for this learning session, this should be enough. Now, let us see what the include files are. I'll pause for a moment. I'm trying to edit this dyna.k file just to see what is inside. And I do it in Notepad 2, which I have found is quite a good editor. Now, if I go inside, I'll find that we have this model, vehicle environment model, which has the sled model, And then we have this dummy file, which is a 50th percentile rigid FE dummy, and it's quite old, but that's the one we have here. And then we have the driver belt model. So I've put the sled model in one file. The dummy file is of course always separate, and you should always keep it separate. And then we have the driver belt model in a separate file. And then of course we have other things like control termination and a few other things, and then star end. And when you submit dyna.k, it will start running the entire model. Now let's go back to the model and say a few things. Firstly, as soon as you read in a file like dyna.k, master file, or a dummy file, if there is a valid tree file inside the dummy, then it will automatically go to the dummy positioning panel. This is the dummy positioning panel. And if there is a valid tree file inside the dummy, and I will tell you what the tree file is soon. But if there is a tree file, then it will automatically go into the dummy positioning panel. And that will tell us that the tree file is alright, and LS pre-post understands that there is a tree file which is valid. For now, let us go out of this dummy positioning panel and discuss a few things. First of all, on the right hand side and also on the bottom, you can see many icons. And underneath each icon, there is also something written in English, like mesh here, geo tools, model, element tools, and all that. This row, the first row on the rightmost side, is always common. But when you click one of them, the next row changes. Like if I press this button, everything changes. When I press this button, everything changes. So this second row changes, and these items are dependent on something else on the right hand side. Now, a few years ago in LS Prepost, when you launched LS Prepost, only the icons used to come and not the names in English. I requested them, and maybe others did, to have this as default. That means when you launch first, both the icon and the name will appear. Here also you can see icons and English names, because without the English names, what the icons mean are really difficult for a new user to understand. But let me tell you where to look for these and how to change them. First, go to this view panel on the upper left, and let's pull it down, and here we have toolbar. And on the right of the toolbar you have this, and you can see text right, icon right, and text and icon both. Now let's do icon right only for now. We'll change it back just to show you what happens. And you can see all the names have disappeared, only the icons are there. Now you can do the same for bottom. Now I do not know whether it has really become default or not in your case. So if you, while launching or after launching LS Prepost, if you find that the English words are missing, then you can do that here. View, come down to toolbar, and then text and icon right. Okay, and soon the words should be coming up. Now at the bottom also the same thing is there, toolbar and text and icon bottom. Now there could be many things, and therefore we have something called an extra bottom toolbar. It depends on the width of your screen. Now, with this, you can see I just turned it off, and now it has stopped in one line. There's only a single line, but there are two arrows here, and if you click it, you'll find it should be there's something underneath it. It is not coming up here for some reason, but when you click these, it should come up. What is on the other side? There are some hidden things. So in order to bring it back, we say toolbar and extra bottom toolbar. When that happens, you can see it has come here and then back here in plot. Okay, so you have to know what these arrows are. And on this side, for this line, there could be some things underneath. Okay, and you have to know how to get them. By clicking these two arrows, you're bringing up some things for this row, the second row on the right. There is something else, and that is I prefer a white background, but you can change the background to black by changing background color. Okay, and this, it becomes black. If you like it, you can change it, and then clicking it again will make it white. Now let me pause for a moment and see something, and then we'll start again. Now, when you launch LSP Post for the first time, it might not be either white or black. So let's go back to View and see this background. And I prefer plain. Okay, that's what I've chosen. Now, if you do fade, it will be something else, and you can try those. But I prefer plain. So I always make it plain after launching. Now, once you have done that, if you close your LSPP session, then LSP Post will remember what you set last time, and it will bring it back, bring that certain thing, the background back, the whatever few settings that you had might come back, and so you do not have to do it all the time. Now, with that, let us go into some of the things which are important for us. I just gave you a little bit of hint about what these buttons are and how to have names with them and all that, just to make your life easier for now. So let me pause a little and then we can continue. There was one more thing which came to mind, and that is there are two GUIs in LSP Post. The older GUI used to be this, and I learned LSP Post with this GUI, and for many years this GUI was all I knew, and I was very comfortable with it. You can click the button here, it will bring up other things. Now you can click this and it will bring up other things. Okay, but they decided to change GUIs and make it this, and I'll tell you how to go back and forth. Now, having worked with the new GUI for the last 2 years, I have become used to the new GUI. And let me say that all the new development of LSP Post is being made in the new GUI. They are not introducing anything new in the old GUI, which is this. Now, everything in the old GUI will still work, but there are no new things being introduced here. And I have heard that LSP Post development will finally not have this old GUI anymore, and they will have only the new GUI. Now, firstly, how do you go back and forth? Many of you might have learned LS pre-post with the old GUI, just like myself. So if yours launches up with the old GUI, how do you go to the new GUI? It is by pressing the button F11. Now, there is a point here. In Linux, just pressing F11 will take you to the other GUI, the new GUI. And over there, if you press F11 again, it will come back to the old GUI. But I have found that in Windows environments, like my laptop, you have to press the function key button and then press F11 together. And my function button on my keyboard is the lower left corner button, and I'm pressing Fn, function, and then F11. And it goes to the new one. Now, many of you might have become used to the old GUI. How do you learn the new GUI? This is something that you should try to understand. And the LSPP developers have done a wonderful thing here. And that is, under help here, they have a line called old to new. Now press that and release it. And you can find that the old GUI is coming up. The essential buttons of old GUI are all coming up. Say this is 1, and supposing you wanted to know, you know what to do in ident in the old GUI. You know that on page 1, this ident button is there. Now, you are in the new GUI. How do you find the same thing, same functionality in the new GUI? So, if you just bring this up here and press ident, okay, you'll find the new GUI taking you to the ident panel. Okay, if you want to do blank, okay, I'm pressing the blank button. It will take you to the blank panel of the new GUI. Okay, and this is a huge help, because if you are used to the old GUI, then you can learn from that where the new GUI is. See, notice when you press blank, it takes you to the new GUI, and element tools is highlighted here and blank is highlighted here. Let's go back to ident. Ident. Okay, element tools is highlighted here, ident is highlighted here, and all these new pop-up boxes are coming up. So this is a huge help. You can learn the new GUI very easily through this and slowly transfer your knowledge from the old GUI to the new GUI, because you will have to learn the new GUI if you are going to use LSPP. All the new developments are going on here, and we will all require the new developments of the last 2-3 years for the work we will do. So please get used to the new GUI in this way. And I will now pause for a moment and then come back to the next step. Now, let us come back to the dummy positioning panel. Remember, we had initially, when we launched, we were already in the dummy positioning panel. But we got out of it temporarily to talk about some other things. Now, how do we go back there? On the rightmost line, where my mouse is, go down to safety and click that. And in this new line that comes up in the second one, you have dummy positioning. Okay, now let's click it, and we are back to that dummy positioning panel. Now, at that time, I had said that if the dummy has a valid tree file, then it will automatically take us into the dummy positioning panel. So where is this tree file? To find that, let's launch the dummy file. This is the dummy file, okay? And let's launch that and see what we get. Launch that meaning we are not launching an LSPP, but we are editing the file. I made a mistake by saying launching. I'm not launching. I am trying to edit the file and see what is there. Now, in my notes, I have said go down to line 15,480. So it is really at the bottom of the thing, and to go to a line in Windows, in Notepad 2, you have to say Control G and then type in the number. Control G brought me this. Control F is to find a string. Control G is to go directly to the line number, and I will do this 480. It is there at the top of the notes on page 5, and I will say OK, and it brings me here at this line, star end. In a dummy file, this is the dummy file. The entire dummy model is in this file. After star end, we have the tree file. And this is the tree file. Now, you should not do anything to the tree file, because if you do and make a mistake, it will not take you to the dummy positioning panel, and you cannot position the dummy. This tree file is nothing but a list of interconnection between the different parts of the dummy, like upper leg, lower leg, foot, how they are connected to each other, and then arm motion, lower arm, hand, all these things, neck, head, right here, all these things are listed, their joint numbers are given, and their axis system at those joint nodes are also given. And when you want to position a dummy, LSP Post will look into this tree file and then adjust everything. That is where the tree file is. Now, in the tree file, you can see some things like these numbers, and you will also find age point. These numbers are no longer used by LSP Post. This comes from an older system which LSP Post no longer uses. So these numbers with decimal point 334.0003, 512, 3048.00, whatever it is, all these numbers, they are not being used. So this entire block under H point is ignored by LSP Post now. We have a separate way to do it, and we will discuss that. Okay. Other than that, there are no decimal figures. Now, in the whole of the tree file, there are no more decimal figures. The only lines with decimal figures are ignored. Now, that gives us a great advantage. And the advantage is this. If you want to take this dummy model and run it, this dummy model is in the unit system, millimeter, kilonewtons for force, milliseconds for time, and kg for weight. So millimeter, kg, milliseconds, and kilonewtons. But your unit system can be totally different. Now, the method to change units is to run a DYNA file and some standard unit conversion files which we also provide. I have made up many of those standard unit transformation files, and you can run a DYNA job with this dummy, and you might want to change it to meters, kilograms, and seconds, MKS. So DYNA will produce a file for MKS starting from here. But DYNA will not convert the tree file because DYNA only reads up to star end. Below this, DYNA will not read. That means DYNA will completely ignore the tree file. And because there are no real numbers in the tree file, it does not matter. You can use the same tree file after unit conversion and put it back into the MKS file. At the bottom of the MKS file, you can just completely write out this block tree file right to the bottom and paste it back into the bottom of the MKS file. Remember, DYNA will not read the tree file, and while writing it out, it will end at star end also. It will not write out the tree file. You have to take this tree file and put it back at the bottom of the unit converted file. And because there are no real numbers, it does not matter. These numbers are being ignored, as I told you. So it does not matter. You can put the same tree file back. And always after changing units, you should remember to take this extra step of copying the old tree file and putting it back to the bottom, under star end, to the bottom of the dummy file. So this is good to know. Now I'll pause again for a moment for the next step, because I have to also read my own notes to see what I've written, and I'm saying a lot of other things that I have not written, which will always happen, but the essential things will all be there. Now I have brought back the model in LS Pre-Post with this dummy positioning panel. Now notice that H point is highlighted and not limb. We'll go back to limb, but for now it is H point is highlighted and the translate button is highlighted. Okay, and we can use this button, this panel, to translate the dummy. But before that, notice the H point given. These three numbers are the H point: 3048 minus 334 point so and so, Z 512 point so and so. Okay, this is the H point. What about the pelvic angle? You can see that the dummy is inclined, seated relaxedly, and there has to be some pelvic angle. So how do you find it? From translate, click the rotate button. Okay, and here we can see that these angles. These will be explained soon, but you can see angle 1 is 180 degrees, angle 2 is minus 22.3 degrees. This is the pelvic angle of minus 22.3. How do we get 180 degrees and minus 22.3 degrees? I will show you. But for now, just notice how to read it. That is what we are trying to do here initially. So let's go to translate, and in the X direction, look at the axis. Positive X is towards the back of the car, and dummy is pointing forward in the negative X direction. So let's just try to move the dummy 10 millimeters in the negative X direction. I have typed 10, but if I want it to go in the negative X direction, I can press the negative button. So you don't have to type negative numbers in many cases. In some cases you might have to, but in this case you don't have to put the negative sign yourself. You can put the number, and then if you say minus, notice the dummy, how it is going. It has gone forward, another, it has gone forward. Okay, now this is X. We could do the same in Y and Z. Okay, just to show you how to bring it up, how to change it. And of course, when we are doing this here, this gets updated. It was 3018, I believe, and we went minus 20, no, 3048, and we went minus 20, so it became 3028. Okay, now we can say undo H point, the last step will be corrected, and if we say undo H point again, the previous one, it will go back to the first one, because we did it twice. Undoing H point twice will bring it back to 3048, which was initial. And we could have done the same thing. For example, we have done a lot now. Reset H point will bring the whole thing back. It will completely reset it in one shot. Okay, but if you just want to do the last step, you can do undo H point. Now let's go from translate to rotate. And there is a little bit more to understand here. Note that the axes are given here, X, Y, and Z. Z is highlighted first, then Y, and then X. Sorry, this is not important. This is X, this is Y, and this is Z. But this button is important. And we are under the system ZYX. ZYX. There is something else called ZYZ, but we do not use it. So just confine yourself to ZYX now. Because Z comes first, angle 1 refers to Z. Y comes second, so angle 2 refers to Y. And X comes last, angle 3 is 0. Okay. Now, rotations of the pelvis are always according to a local axis connected to the H point. And that shows up here. You can see Y and X and Z, red, blue, and you can zoom in there and you can see it. This one. Zoom in, this button, zoom in, first click it, and then the square cursor appears, and we can drag it by the left mouse button and release it. So this is the local axis about which pelvic angles are being defined and pelvic rotations are being performed. Now remember, H point, these are all in global. H point is in global. X3048 is in global. It's not local. Okay, but pelvic rotations are always about this. So how do we get to 180 and minus 22.3? Okay, let us do auto center. I will show you some of those mouse operations where you can, for example, you can translate the dummy like just to bring it into view, not translating the dummy, but just changing the whole thing. Or you can rotate, and then you can either zoom out or zoom in. Okay, so for now, and auto center will all bring it back. And there are some view buttons here like left, and you can click this and this will come up, and you can do right. Okay, you can do some things like that, top, so and so. So let us go back to left. Okay, now I will show you these mouse operations a little bit later. But for now, we are doing rotation and Z-axis. Now, when we release a dummy, you might have noticed that the dummy faces rearward and upright. It is like the dummy is sitting on a chair with its spine straight, but looking rearwards towards the aft direction. That is the as released condition. In that condition, the pelvic angle is 0. The local X will be pointed backwards and will be parallel to the global X that is showing up here in the left side of the screen, global X. The local X attached to the pelvis will be parallel to this axis system. Now from there, the first rotation is about Z-axis, and we rotate it 180 degrees. This pelvic angle is still 0 at this point. So immediately, the whole dummy will rotate about its own Z-axis, which is also parallel to this Z-axis. The direction is same, but it will rotate about this pelvic H point, okay, hip point, which is so important in dummies. Now, and I can tell you what the definition of the hip point is a little later. But that first angle would have been performed, okay, rotation 180 degree about its own Z. Now the Y will be pointing out of the screen because it has rotated. This is local axis. Okay, if you can imagine this right-handed system, X will be like this and Z will be like this and Y will be outside. Now we will do the second one, and that is we will click this one and rotate it, the dummy about Y, about the local Y by minus 22.3, and that will put the dummy in this inclined position on the seat. I hope you are following this. If you take any of our released dummy models, hybrid 3 models that I have worked on, they are all facing rearwards and upright, and you can perform these operations yourself. Now, what is the number of this coordinate system? That is important to know, and that is given here in the dummy positioning panel. Local 1,066,000. This is a number I have given, okay, and LS Prepost will read that from the tree file and put it here. So the local axis is just this, okay, and this is the coordinate system. So where is it written in the tree file? Let's go back to that model and reopen it and go right to the bottom. I'm dragging it down, and here if you go to the tree file, let me find it by searching for end, Control F, end, okay, and close it, and here LCS 1,066,000. This is a number I have put in by typing it in, and when it reads this, DYNA will, LS Prepost will completely ignore these lines. That is why it is ignoring it, because before it I put LCS 66, 1,066,000. And LS Prepost will go to the origin of this coordinate system, and that will be the H point, the origin. Now, what have I done for the H point? Let me explain to you right here. Let me go out of it. It says, do you want to save? I don't want to save anything because I did some operations to show you, so I'll say no. So it goes out. Now let's go to model and select part. When I press model, select part. And let's zoom in by clicking this button and left mouse button, drag and zoom in. Let us take this belt out and many of these dummy parts out. Okay, these are the belts, you don't need them now. Now you will find a small part here, and if you go down, you might find, I'm sure I've given the name of this part part somewhere, and I'm looking for it on the right hand side. This well, in this model I think I have not given the name. Yes, H point pyramid, part number 1,236, H point pyramid, and I have created this H point pyramid here. Now let's rotate a little and zoom in, really zoom in, and here is the H point pyramid. Let us turn the mesh on here, down below in the left, mesh. This point is the H point. Okay, this point is the H point. Now let us temporarily go out of it and plot the coordinate system 1,066, and that is in same model display. And let us think, it is coordinate system, so it must be define coordinate system, I think. Yes, define coordinate, and go down to this, and you see H point local, I've given the name. Let's click this, and here is your that coordinate frame system. Okay, and if you take make it wire element, it might become even clearer. Here in the bottom wire element, we are keeping everything, but we are taking the shading off. This origin of this coordinate system is the H point. But how did I find this point at all? I found it this way. Let's put shaded back. Okay, now this is the upper leg left, and this belongs to the upper leg right. And when you try to rotate them, they will rotate about a certain point in space. Okay, they are connected to the body. This is a simplified dummy, so you cannot understand it properly. But in the real dummy, there are other parts, and we can study some of our refined mesh models also. But here, let us remove these two seat parts and try to rotate the dummy by the upper leg by going into the dummy positioning panel. So we are back to safety and dummy position, and now let's change it to limb. Here, H point, limb, and upper leg left. Okay, and you can see two axes have appeared, and the upper leg will be rotating. Say if we change the angle, not so much, but say 2 degrees. Okay, and see, it's going down and it's rotating about this joint. There's a joint here for this upper leg. So for the right upper leg also there will be a joint on the other side. Let's do it a little bit so that you understand what we are doing. Upper leg right. So immediately these coordinates, a joint will appear, and we can do the same down. Okay, now imagine these two joints. The position of these joints, upper leg left, the joint is here. Imagine the spot on the screen here, and upper leg right, the joint is upper leg right, the joint is here. Now if you drew a straight line between this joint on the upper leg right and the joint on the upper leg left, okay, for rotation of these upper legs, then the center point of this is the H point, and this is right in the middle of the dummy. For all dummies, the H point, at least for the hybrid 3 dummies, as far as I know, the H point is defined that way. You take the rotation point of the left leg, the rotation point of the right leg, and draw a straight line across the dummy, and the center point will be the H point. So the H point is here. This is how H point is defined. And I've shown you the coordinate system which is there in the model, and also the fact that I've referred to that coordinate system in the dummy file itself, in the tree file. Okay, so it is there. So let's not waste time on it. Let's go back to this, to other things which are more important. Now, let us do a couple of limb rotations. I've gone to limb, and what we are doing is lower arm left here. Okay, and immediately notice that a couple of axis systems appear. In my release dummy, these were coincidental. That means there was no relative angle between these coordinate systems. One of these coordinate frames is attached to the lower arm, and the other one is attached to the upper arm at this joint. And when you rotate them, these coordinate systems will rotate with, one of these will rotate with respect to the other, and LS prepost will calculate the angle between them, and it will display the angle here. For example, it is minus 52.44 in this, and the axis is Z axis. Okay, remember we are following ZYX, and sorry, I should not have pointed to this Z. I should have pointed here. This is just a selection. Okay, but ZYX angle 1 is Z, and so it is minus 52.44. Okay, now let us go to remember, angle 2 and angle 3 in these are active and shows up as 0. Okay, why are there 3 angles? By looking at it, it seems to me that it is a spherical angle. Spherical angle. And therefore, you can rotate this hand in any direction. You can rotate it in about Z, you can rotate it about Y, you can rotate it about X. And there are some limitations to it, and we'll come to those limitations later on. They are called stop angles. So let us rotate about X, and let's see whether we can rotate the left lower arm about anything. And okay, and it says stop angle reached. So about X axis we cannot rotate it. About angle 3 we cannot rotate it. Let's see about Y, and here also we cannot rotate it. In our refined mesh dummy, you can rotate the lower arm in different directions, but in this simplified dummy we cannot rotate it. But still, the angles are there, and it is a spherical joint, so technically you can rotate it about different directions, all axes, but here we have not allowed it by putting stop angle, and I'll show you what the stop angles are. Okay, so let us go to the foot. Okay, and let's go to foot and auto center, and here at the feet the 2 axes have come up because I had positioned the foot. Okay, but notice here it can only rotate about X, local X, and this local X is pointed in the actually along the global Y. Okay, and I have set it up that way. You could have done something else with the axis also. But here notice that Y and Z are shaded. And why is it shaded? Because this, if you go to the joint, it is defined as a revolute joint. And in a revolute joint, this foot can only rotate about one axis. So I did not need stop angles for Y and Z. Y and Z angle rotations are not even available for this joint. And that is why it is shaded out. And therefore, that ZYX or something, that is not even here. There is only one axis about which the foot can rotate in this dummy. In another dummy, it can be different. But in this dummy, you can only rotate the foot, say, like this, or upwards. And there will be a stop angle in this, about this axis also. You cannot go on doing it. Okay, a time will come when it will not allow, LS-DYNA will not allow it to go any further. See, stop angle has been reached. So you cannot go any further. But the important thing here to note is that for this, Y and Z rotations are not available because this is a revolute joint. Now, let me pause a little and before I go to the next step. We are still discussing the foot joint. We are on top of page 7 in workshop 1, and we are discussing point 8 here. And it says, notice the two different types of joint IDs. What it is asking you is to refer to these. And this is the constrained joint ID, and this is the constrained joint stiffness ID with this extra letter S there, stiffness. So what is the difference between joint and stiffness? For linear forces, the forces are measured from a joint. But for all moments at the joint, those are measured by the stiffness. And how do they look? Let's click this button. You can go to the deck and look for this joint ID with number 1,000,008. And you can look at the stiffness ID which is numbered 11, and I have printed those out in the manual. But for now, let's click it, and this comes up. This is a joint. Remember, I told you it is a revolute joint for the foot. So this is constrained joint revolute. And there are node pairs. Now, anyone who knows revolute joint in DYNA knows that there is a pair of nodes at one end, and there is another pair of nodes at the other end, far away. And one pair of, the nodes at one point, one of them is attached to the upper body, one is to the lower body, or these are attached to different bodies. The way it is set up is this is connected to one body, and this node is coincident with this, but this node belongs to the other body. Then this node is far away from here. But this node is connected to the same body that this node is. So these two are connected to the same body. And these two are connected to the same body. These two are coincident at this exact same point. And these two are coincident at exact same point. Their x, y, and z coordinates of this and this should be technically identical. And the coordinates of this and this technically should be identical and also quite far away for the revolute joint to function. Now let's say done here and press the joint stiffness ID, and here it is. Okay, now this is the joint ID 1,000,011, and there are two parts, PID A and PID B, and two of those nodes, remember, from the joint are connected to PID-A. The first and the third nodes are connected to PID-A, and the second and the fourth nodes are connected to PID-B. And there is also a coordinate system given based on which the angles are being calculated. And there are some stiffness values and other things. And not everything is populated here because we did not need it. But this joint is functioning purely by these two figures. This is how the joint gets its stiffness. But what is important here is this. Okay, this is a stop angle about the local x-axis, and that is why we have given phi. And this is in the negative direction, and in the positive direction the stop angle is 50. And as you know, it can only rotate about x-axis, so only these two are there and the others are not even there. But once the starting point is whatever the zero angle is, it was given in the as released dummies. That was 0. Okay, after that you can go minus 20 in the negative, about the negative side of the x-axis, and 50 degrees positive. Okay, so these are the stop angles, and you cannot exceed these rotations. As you can understand in your own limbs of your own body, you cannot arbitrarily go on rotating them. So all dummies have stop angles, and this is where the stop angles are specified. Now, remember the joint and the stiffness. Let us do done here. The joint and the stiffness are basically at the same point. Okay, but the definitions are different based on the two blocks I just showed you. The definitions are different. Now, remember this, that you can have a joint without a stiffness. Theoretically, DYNA will not mind. You can have a joint without this stiffness. You do not have to give rotational stiffness all the time. But you cannot have a rotational stiffness defined, but not the joint. This cannot exist by itself without this. But this can exist by itself without this. And this is a very important point that I quickly wanted to mention. And I'm pausing. At this point, we are on number 9, page 7, workshop 1. And the notes say, belt movement together with dummy movement. And this is an extremely important thing for anyone in a practical working environment. And I want to show it to you right here before we go to anything else. This was not there before. This was introduced only 2 to 3 years ago, I think, if I remember right, not more than 4 years ago. Okay, in 2008, 2010, it was not there. And that made life very difficult, even for me. And I gave in my course notes, which I had prepared in 2010, different ways of doing the same thing, but it was very difficult. And then I worked with the LS pre-post developers, and I told them that this has to be done. Now, what is it? Let me show you. Let us get out of dummy positioning. We don't want to save anything. See, when you are going out of the dummy positioning panel, if you have made changes, LS pre-post gives you the opportunity to save that dummy positioning. Okay, you have positioned everything, so it should remain. So you can say yes there. But here I do not want to save anything, so I have said no. Okay, and I've gotten out. Now take this model. I've pressed model here, select part. Okay, and let's click the roof and the windshield away. These are representative, and I will come here, okay, to this view. Now let's do done here. get out, and let's go back now to safety and dummy position. Okay. Now let us go back to H point here. Okay. And let's show you a dummy movement of say 10 millimeters in the negative X direction, that is towards the front of the car. Okay, and because it is H point, it is like this, so we press negative, and you can see the belt is not moving. The belt is going through the dummy. Okay, further you go, the belt is going inside the dummy. Now this used to be a huge problem, because even for a little bit of dummy movement, you would have to do something about the belt to make it fit. And anyone who had worked with LS-DYNA belts in LS pre-post knew that redoing a belt is a huge problem. So what did we do to make it happen? Okay, let's reset H point and let us get it back. Now we have a button called Move Attached Fabric Belts. Let's highlight it. Now let's do the same thing. But before that, we have to pick the belt fabric. So let us click this belt. And a white line comes around the edges of the belt, showing you that it has been picked. It has just been picked. Now this belt, the chest belt and the lap belt, are in the same part. So both have been picked at the same time. In my recent models, the chest belt is in one part and the lap belt is in another part. And we have a reason for doing that. Okay, but in my older models like this one, they are put in the same, and so you cannot separate them. They are both picked at the same time. But now see, when you do the same translation of the dummy, the belt is moving along. You can move any distance. The belt is moving along. And now you can save this and write out the belt, and your belt will remain positioned on the dummy. Now let's go back a little bit. Okay, a little bit. We can do H point, reset H point, and just move say 10 millimeters or 20 millimeters. Okay. Now let's do a rotation of the pelvis. Now as soon as we go out of translate and rotate, the belt selection goes out. But we want to change pelvic angle by say 5 degrees. Here I'm pressing 5. And we are going to do 5 degrees positive. That means the dummy should be moving forward about its own H point. Rotate. Okay, this is a rotation. Now here we have to click Move Attached Fabric Belts part again. And we have to click the belt again. And both belts are being picked. Now see, I'm doing positive. Okay, 5 degrees. Oh, sorry, I forgot to change the axis. Okay, so I go back negative. It was Z by default. For this rotation, pelvic angle rotation, let's do Y. We have to do Y first. Okay, and now positive Y, it is moved. And the belt remains routed. Okay, and this is a huge thing. There are other things going on here, which I have to show you later. But for now, just know this, that you do not have to read out the belt for small dummy position movement in translation or in rotation. Remember to click this, Move Attached Fabric Belts, and then pick the belts you want. Okay, if this and this are in separate parts, pick them individually, and you can know whether they are picked with this white border line that you see on the edges of the belts, and then you know, and the belts will get automatically adjusted. Now this is a huge time saver, and I'm very happy that I requested our LS Prepost developers to do this, and they were also able to do it. And they have done a lot more work. This was the first step. Then they did a lot more work on these belt segments, okay, to make this work properly. And much of it was on my request, but they were able to do it. Say, let's do reset H point completely once, okay, and show you something while we're discussing this. Let's zoom in and show you something. Let's press the shrink button, okay, and you can see the individual elements. Now, let's translate the dummy, okay. Even if this belt moves, we have to move attach belts and pick, and this belt has been picked, okay, and we are focused on this area. Now let's do -10, okay, another -10. See, even if the belt moves, only this node should move, okay, and this element will get longer and longer. That is what you would expect. But no, if you notice carefully, all these nodes are being spaced equally, and all these lengths of the belt remain the same. Let's go back, reset H point, and now notice carefully. 10 millimeters, okay? These are the lengths, all equal. They remain all equal. They remain all equal. They remain all equal. You do not have to make any adjustment to this belt segment. And that is going on everywhere. At the buckle, okay, wherever there's a buckle or a slip ring, like a D ring, this will go on. So it is really smart now. It can do things it could not do before. And this last step that I showed you, happened within the last 2 years or 2.5 years, I think. And our LS Prepost developers could do it. And that is a huge advantage. Now, you will really like it if you are going to use LS Prepost for positioning the dummy and then adjusting it later on during your regular work. So let me pause again for the next step. Let me just now show you quickly some of the zooming and panning and rotating options with the mouse. So far we have used the zoom in button, a zoom out button and things like that, auto center. Auto center is of course very important. But basically the mouse operations are done with the left mouse button, the middle mouse button and the right mouse button. And the two keyboard buttons which are important are Shift and Control. Okay. Now I'm pressing the Shift button with my left thumb, and with the left mouse button I'm just dragging it. I pressed the Shift button is pressed and the left mouse button pressed, and I'm just dragging, so I can rotate it this way. Okay. Now what about keeping the Shift mouse button down and the middle mouse button? Okay, and I can translate the whole model from left to right or up and down, okay, by the middle mouse. Now keeping the Shift button down and the right mouse button, I can zoom. If I drag it towards myself, it is zooming in, and if you drag it away from yourself on the pad, on the mouse pad, then it will become smaller and smaller. Okay, and of course we can always say auto center. The control button for these operations I hardly use, but it will go into wireframe mode, I think. Okay, I press the control button and the left mouse button. I can do the same rotation, but it will be in wireframe mode. Now what about control button and middle mouse? Here, panning up and down, middle mouse. The operations with the mouse are the same, but shift and control do different things. Okay, it just, if you are in shaded, shift will keep you in shaded, but if you do control, it will temporarily switch to wireframe so that you can see things a little better. And for the last step, I'll pause again and review it and then come back to the last step for this workshop. We are now on item 10 on page 9 of workshop 1, and I'm trying to show you how to save the model using subsystems. Now, what is a subsystem? We read in the DYNA.k file, okay, which is the master file, and inside that there was this sled model with the seat and floor pan and other things, and then there was the belt model separately, and there's a dummy model separately. Now, how do we save the dummy changes into the dummy file, the belt changes into the belt file, the vehicle changes to the vehicle file? These are subsystems, and to do that we go to the top left where file is and drag down, and now save as. Don't try to save, that might be a little dangerous. Save as, okay, and then save keyword as, this top one, not active. For a general save, don't save active, always save keyword so that the whole model is taken. Now this is the selection, and I'm leaving the left mouse button. It was all being done by the left mouse button, so I'm leaving it. So this panel comes out. This is the save keyword file. Remember, save as, save keyword as. Okay. Now here by subsystem is lighted. It's been picked. Okay. Here there is no name. If you take it away, everything here will become shaded, and you can give one name. Okay. And the whole model will be put into that one name. That means the directory name is given, and you can go right to the end. Okay, it's going, and here you can give a file name, and the whole model will be saved in that file. But we do not want that. We want by subsystem, and this is a very useful operation, and the LSP post people have tried to perfect this system. Now here you'll find the subsystems. DYNA.k is the main file, but it is also treated as a subsystem. But within it they have vehicle environment, the dummy, and the belt. Okay. Now we have something called, if you save it in this condition, then it will overwrite your original files. And you do not want that. You absolutely do not want to overwrite your originals. So we have given an option called name prefix and name or name suffix. Okay, you can give a prefix like mod1 dot prefix, and we hit apply. Mod1. Okay, you can give your name, but I'm just showing you mod1, apply. So what happens? Okay, all these subsystem names have become, we have put prefix, so in front of the names mod1 dot has appeared, mod1 dot, and I've hit apply. So all the names have, all these file names have mod1 dot, and the dyna.k file itself has mod1.dyna.k. Now we can press the save button here. Okay, save, and it will put all the changes into the different subsystems with different file names mod1. We can give a suffix also. Okay, let's say suffix like say tail1. Okay, because it is a suffix, it will be put right at the end. I do not like suffixes here, I like prefixes, but I'm just showing you. Okay, dot tail 1. Okay, apply. See, you have mod 1 in the beginning and also tail 1 dot k. Okay, you can have that. Okay, and the dot k is still the end at the end, but the tail 1 name comes at the end of the thing. So you have both starting with mod 1 and then tail 1 to all these files, and now you can press the save button. And this is very important. Now if you make a mistake and save it without these prefixes, either the prefix or the suffix, then it will overwrite your original. I suggest that when you do large amounts of modification runs, copy your originals to a different directory. Work in that directory. So even if you make the mistake and it overwrites, you still have your original in some other directory. These are all safeguards, because if you make a mistake in an actual job, you will be very frustrated that you did something wrong and you lost everything. And you cannot afford to lose your originals. And you have to safeguard. So all these are done in LSP post nowadays. Let me pause one more time and let's see whether I've left out anything. Now, there is something important written at the bottom of page 9 and on page 10, and let me just discuss that. Okay, it is this, that when you save a file, which I told you moments ago by subsystem, and you get these new files, but LSP post cannot handle all the comment cards and keep the comment cards exactly where they were in your original. Now, if you look at my decks, I have put a lot of comment cards. And these comment cards are connected to the block of data which we are discussing, so that we can quickly refer. But if you read into LSP post and you write it out, then LSP post will give you a correct deck which you can run. But it might not be able to keep all the comments together with the relevant portions of your deck. So sometimes in order to do that, keep those comments and everything, I do a lot of hand editing. Okay, and how is the hand editing performed? Let me just tell you that here. That is what we are trying to discuss. Supposing we go to safety, supposing this is the original model, and all we want to do is a little bit of dummy translation. So safety, dummy positioning, okay, H point. Now I have been typing numbers here, okay, but you can type the H point directly here. Let me show you this. Supposing this is 10 millimeters minus, and it started with 3028, okay. Now negative will make you 3018 and the dummy will go forward, okay. But in this, I could have just changed 2 to 1. If the arithmetic is easy, you know exactly what to type, and then if you make any changes here, you have to return. Hit the enter button. Enter. Now the dummy has moved forward. In each of these, remember, if you change these by hand, just hit return, enter. There is no apply button for these X, Y, and Z. There is no apply button. There is an apply button, but I don't think it works. I think you have to do, let us try the apply button. 1 and oh, it is working now. Okay, I didn't know that. Previously this apply button did not work. But if you type numbers here, hit apply or hit return, and it will do the same. Okay, now, so I'm showing you another way of translating the dummy instead of just typing here. But these numbers are cumulative. This is absolute, okay, and this is cumulative. If you press 10 twice, it will go 20. If you press it 5 times, it will go 50. So let's go back to reset and let's move attached fabric belt parts. And let's pick the belt. It is highlighted. And now let's do here distance -10. Okay. And the belt has moved. All these belt segments have gotten adjusted by LSP post. The belt has moved. And so you'd say done. Now you're saying you are leaving occupant positioning interface. Do you want to save all changes? Let's say yes. We want to change this translation of the dummy and the belt and everything. Now we are going to file and we are saving as, save keyword as, okay? And we are into subsystems highlighted here. This is shaded away. So you have to put, we are doing subsystems and say trans 10 millimeter dot, so that you know that these are the ones with translation of 10 millimeter. And we say apply. We have to hit apply, otherwise the name won't go here. And so all these will have trans 10 millimeter. Now we save and it has done everything. Okay. Now this DYNA.file will have these names included in it. Okay, sorry. Trans 10 millimeter, trans 10 millimeter, this all will go into this model in this master file. Okay, the new ones will be included. But note what we have done. In the dummy, we have done nothing but change the nodal block. And in the belt, we have done nothing but change the nodal block. So we can save. Okay, we save. But we can ignore everything in that saved file except the new nodal block of the dummy. And we can ignore everything else in the belt file, the saved belt file. Okay, the saved belt file. We can ignore everything, just extract the nodal block because we have done nothing else. Now we go back to our originals and make copies of the dummy file and the belt file. Okay, and in the new dummy file, copied dummy file, we put this new nodal block. We remove the old nodal block and insert the new nodal block. And in the belt file, we take away the old nodal block and we put in the new nodal block. And in the vehicle file, we have done nothing. So we don't have to do anything. We can keep the original vehicle model. Now if you take these new models and include them in the master file and read it back into LSP post, you should find this dummy in this change position and the belt all routed perfect. Okay, you should always check what it has done and you will find it perfect. But look what has happened. In your files, the entire file is organized in the way I gave it to you. You have all the comments together with the relevant sections. And you can very easily keep understanding. You know, if you're completely relying on LSP post or any other preprocessor, then, and you are just reading in and writing out and reading in and writing out, if they are good preprocessors, they will give you a correct file all the time. But after some time, you will find that you cannot read your own files. You cannot understand because all the comment cards are all over the place. And this happens to almost every preprocessor, not only LSP post, but other preprocessors. And to avoid that, try to hold on to your original files as much as you can and just change the relevant portion like a nodal block. Sometimes I change element blocks. Sometimes I change other things, but I try to keep my original files by doing some hand editing. And these are all working tips, things which will finally make your life easy. You might have to do a little bit of hand editing and you will get used to it. But if you do it that way, finally you might become better at analysis simply because you can understand your own decks. instead of totally relying on the preprocessor. Reading and reading out, you will get lost after some time. So with that, I'm ending workshop 1. Workshop 1 has became very long in time. The time that I'm noticing now is 1 hour and 16 minutes or something. 1 hour 25 minutes. 1 hour 25 minutes. That's quite long. For most of the workshops, I think, except the very last one, it will be much less. And it also became long because I told you a lot about LS pre-post and many other things while doing workshop 1. All those things are important and I had to tell you somewhere, so I told you right here. So anyone who has gone through workshop 1 and has listened to this audio-video demonstration might actually find it much easier to do other things in other workshops and other things. And I will not explain so much about LS pre-post. I won't repeat the same things in the future workshops, and we can move much faster. Of course, new things in LS pre-post will come up, and I will talk about those. But that might not take so much time as in this first workshop. Thank you very much, and we are closing workshop right now.